Hello everyone, welcome to our Engineering Exploration course project, which we'd like to call the GRIF machine. GRIF in French stands for claw, hence the name. Before we move on, I'd like to thank our guide and mentor, Ma'am Radhika, without whose constant support, none of this would have been possible. Initially, each team was given need statements. After analyzing the need statement and coming up with the possible objectives, functions, and constraints, we came up with the following problem definition, which was: design a game machine which is fun and attractive to people. It should be portable, user-friendly, and must not exceed a volume of 1 cubic meter. It should work for at least 3 hours continuously. Overall cost shouldn't exceed 3,000, and children around the age of 7 should be able to use it. The machine should be able to indicate the start and the end of the game with a buzzer. The claw should be able to hold and drop objects, and a car should be able to move the claw wherever the user wants. Next, we have the function tree. Before starting our project, we were told to divide it into various subsystems to make our work simpler. Hence, we came up with the following functions for our project. They were: the claw should be able to hold and drop objects. A timer should display on the serial monitor. Buzzer should indicate the end of the game. A dispenser, that is a bent pipe, should be able to send the rewards out. A car should be able to move the claw to the desired position. It should be able to move front, back, left and right. Characters should be taken from the phone and passed to the Arduino via the Bluetooth module, which will control the movement of the entire system. Next, we did the functional clustering. That is, we grouped all these functions to give us 5 subsystems, which were: holding objects, indicating the start and end of the game, dispensing objects, movement, and control. Keeping these functions, objectives, and constraints in mind, we came up with 4 different concept designs for our project. Now let's take a look at them.
Further, moving towards the conceptual design. First of all, you should know that what is the use of generating many conceptual designs for a single problem definition. As you know that everyone has a different plan and a design to bring the problem definition in existence. So we should allow all the members to keep the point of view and we can select the best one among them. There are some common things in all the concepts, and that are: the car is controlled with a mobile, and a sensor, timer, digital display and a dispensing pipe are the common things. Coming to the first concept, the claw with dent is attached to the robotic arm for fitting the gift for the containers. And the board, there are 3 containers which are connected to each other and rotate at a set speed so that the probability of hitting the object decreases. The indicators are placed in the central empty space and the run track is loop type. And further to the second concept, there is an electromagnet fixed to the robotic arm. We can attach a small metal on the gift wrappers which get kept in the containers. In the board, the track is a curved part and start and the end point are on the different and opposite side of the board. The third concept has a vacuum attached to the robotic arm. When the objects are near to the vacuum, it holds the object and then comes towards the dispenser and leaves the object by reducing the vacuum suction. In the fourth concept, there is a metallic hook which attaches to the robotic arm, which picks the gifts like a fishing bow and then it comes to a dispenser. And the main part is of selecting the concept, which we can do with the help of a pug chart. Now, what does the pug chart stands for? A pug chart is a qualitative technique used to rank the multidimensional options of a set, and most importantly, it is not weighted to allow a quick selection process. According to the chart, the first concept was being selected because it has more points in the area of fun, attraction and mainly safety measures.
Now let's move on to the virtual implementation of the project. This is a 3D model of the entire system. It consists of a car with a robotic arm mounted on it. The robotic arm at its end has a claw which opens and closes to hold the objects. This car is supposed to move along the path provided in the board. It moves front, back, left or right depending on the input given by the user. The board consists of a path for the movement of the car, and on one corner it consists of 3 containers mounted on a disc which rotates slowly. These containers contain the objects to be picked by the user. and on the other corner, it consists of a bent pipe to dispense the objects out of the system. Now let's have a closer look at the model. The car consists of 4 DC motors of 15 RPM each. The robotic arm is mounted on the car with the help of an L clamp. The robotic arm contains 3 servo motors, one metal servo at the base, one toy servo at the joint of the 2 links, and one toy servo to rotate the gears for the opening and closing of the claw. Next, we have the circuit diagram of the entire system. We need 2 Arduinos, one to control the claw and the car, and one for the board. The claw and the car part consists of 4 DC motors, 3 servo motors, and batteries for power. The direction of the DC motors is controlled by 2 double channel relays. The car moves front, back, left or right depending on the input given by the user. Whereas on the other hand, the servo motors move by an angle of 10 degrees depending on the input. They either move 10 degrees clockwise or 10 degrees anti-clockwise. The circuit diagram of the board consists of power supply, a motor, a buzzer and a push button. When we press the push button, the motor starts rotating and a timer begins, which count downs from 60 to 0. Once the timer becomes 0, the buzzer starts buzzing. This indicates the end of the game. Next, we have the flow chart of the entire system. When we press the button, the game begins. The timer starts and goes on decreasing. The stepper motor on the board starts rotating, hence the containers rotate slowly. And depending on the input, the car moves forward or backward, then left or right. Then after that, the user gives the input for the claw. The arm moves up or down based on the input given. Then once the claw is set at the right position, it opens and closes to pick the objects in the containers. Once the objects are picked, the car should move in the path and drop the objects in the dispensing bent pipe. And when the timer becomes 0, the game ends, the stepper motor on the board stops rotating and hence the game stops. Now let's take a look at the materials required to build this project. First, to build the robotic arm and the claw, for the framework we need acrylic sheets. And to move it, we need 3 servos, one metal servo and 2 toy servos, one L clamp to join the robotic arm to the car, screws for attachment. Then we need an Arduino to control the input, battery for the power supply, and connector to join the claw to the robotic arm. Next, for the car, we need 4 DC motors of 15 RPM. The base of the car will be made of a metal sheet 20 by 15 centimeters. We need 4 wheels of 6.5 centimeter diameter, one Bluetooth module to pass the characters to the car through the Arduino, 2 2-channel relays for the controlling the direction of the DC motors. To build the base of the game, that is the board, we need 2 foam sheets which will be cut and joined in the form of a box. For the containers, we will make 3 holes in an acrylic sheet and will place cups in that holes to hold the objects. Screws are needed for joining, stepper motor for the rotation of the disc, dispenser, that is bent pipe to dispense the objects out, adapter for power supply.
Coming towards the motor sizing and battery sizing of the entire system. The torque for 4 DC is 20.25 kg/cm. For each individual it is 7.35 kg/cm. Hence, according to the motor specification table, we need 4 DC motors of 15 RPM each. And DC motor draws a maximum of 300 mA at a maximum load condition. And it should last for 3 hours. So the battery capacity should be 3.6 ampere per hour. Then function specification. Movement, the car should move forward, backward and right and left. Controls, phone control, it should send appropriate character to the microcontroller to control the car and the claw. Inducted and Buzzer should buzzer for 2 seconds. Holding objects, claw should close for 60 degrees to 0 degrees. For dropping the object, claw should open from 0 degrees to 60 degrees. Display, it should show the time remaining in the seconds. Dispensing, a bent pipe which is fitted in the board should give the rewards for the user. Storage, the containers containing rewards should rotate clockwise at a set speed. Now coming on the modeling and simulation. Modeling is the process of developing a mathematical representation of any surface or an object in 2 dimensions. Simulation is an approximation operation on a system and its work using a particular system. There are 2 parts, one a car with a claw and another one with the board. Car model consists of 4 DC motors which control the motion of the car and 3 servo motors to control the motion of the claw and 3 9-volt batteries. This is the code. We should give the input in terms of characters. Input A and B are related to the first servo, A for 10 degree up, B for 10 degree down. Input C and D for second servo, C for 10 degree up, B for 10 degree down. Input E and F are for the third servo, E to open the claw, F to close the claw. And for the motion of the car, G for back, H for front, I and J for left and right respectively. Coming to the board part, it consists of Arduino breadboard and a DC motor encoded with a 9-volt battery which helps in rotating the containers, and a buzzer which acts as an indicator. Let's come to the simulation part. This is the code of 28 lines. We should give the input in character form and send it to the program. Then the motor will start rotating. You can see the time is decreasing from 60 seconds. When it will reach to the 0, the buzzer beeps and the motor will stops. Now we came in the last stage of the timer. You can hear the sound of the buzzer in few seconds.